Hello there, welcome back to the 25th session on Oracle Architectural Journey. Let me share the screen. We have been discussing this one on our practical hands-on. We completed our practical up to this place, getting the details from S1 SEN timetable. So let's continue from there. The next thing is select current SEN. We got the current SEN from the previous this table also we can get it, but there is another method, select current SEN from BW database. So if you just run this command, you can see select that, and yeah, so this is the current SEN on my database as per this time 4852. Yes, so 4.9. So that's the current SEN. So what I can do, because SEN we know it is a chronological monotonical and it's based on time, it maps directly to the database time. So we should be able to derive the time from this SEN, and vice versa. If you have the SEN, we can convert it to time. If you have the time, we should be able to get the SEN. Now how to do that? Using this particular function, select SEN to timestamp, and we need to give our SEN number. So let's try that out. Yeah, let's get a new command, SEN to time. Let's copy that one. Yeah, let's see how it converts. Okay, now you can see that particular SEN, the time was 9:28. Yeah, apparently it's correct because December 30th, then you can see it is 9:29 the system time and 9:28 converted it time. And similarly on the other hand, I should be able to get the derive the SEN from this time. So let's try the other function. So for that we need to use another function, timestamp to SEN. Earlier it was SEN to time, now timestamp to SEN, and we can try out this one. Let's try this command. Select timestamp to SEN. Yeah, two timestamp we need to convert, and this one we let's put the date as today is 30th and December 21, and we need to put in 24 hours because I am putting 24-hour clock, and it is night anyway. For 9 is okay, it's morning time. 09:28 and 00 seconds. Yeah, so that's the time. So let's try what's going to happen, and it should give the SEN. Let's run that one. Yeah, it gave 4.8. Yeah, rather close number. Earlier it was this is our SEN was 4.9, and the number given was 4.8. That is acceptable because the accuracy of that particular conversion, there can be a plus to minus 3 seconds accuracy. So that's why, because the reason is a given time, for a particular given time there can be several SENs. That means in this particular moment, let's say 9:20 seconds, there can be several SENs. Because of that, we may not get the 100% similar same SEN number when we convert it to the time, and again if we put that particular time frame and when we try to get the SEN back again, we might not get 100%. But we can try out something like this. Now I can do, let's say, now this is the SEN given by system. No? So if I get this one, now this is something acceptable I am doing, it's okay, and I can get the timestamp for this one. If we get the timestamp for this one, so that will say 9:28:00. Now if I run this command again, so that will give 4.8. So that is correct now, because I exactly got the SEN for that specific time and I put it back to SEN using the timestamp to SEN conversion, then it gave me that. So that is acceptable. So that's way you can convert between time to SEN, SEM to time. And to get further details on that, now you can see here the time mapping of SEN with time is time mapping of SCN with time is plus or minus 3 seconds. Yeah, there can be variance like that. As this is stored in internal table, Oracle doesn't allow to access information. That's true. It's from the table directly. Yeah, we can't access the information is stored in internal table, x dollar, x underscore dollar tables, kernel tables. We can't directly access, but we can use the function if you want further. To get further details of that timestamp, SCN timestamp, we can use get system change number function. So that is possible. Earlier we got it from this one, select current SCN from builder database, but if you want to get more details, we can take it from get system change number function. This function returns the current SCN as an Oracle number data type. You can obtain the current change number and store it for later use. Yeah, this helps you to retain specific information. Yeah, if you want to do flashback queries, version query, and even for recoveries, so you can use that particular number, and the documentation will tell you about what is that we have. But again, in the documentation, minimum information, as I mentioned, we don't have these things are not properly documented, so therefore you don't get that much of information. Even if you visit there, you will see it is giving only minimal information. Get system change number. So this is what it says. The function returns the current SCN as an Oracle number data type. So that's the same thing that I have copied from here. So that's why minimal information, but we can get a customized query like this, a hierarchical query, because it uses the level, hierarchical function level is there. So we can try out that query. I think I have typed that one. Yeah, so this is I just typed that, executed this query. Now, but it will do select SCN to time as SCN. So it's converting as timestamp. It's converting the SCN to timestamp and getting the timestamp like this. The first column is timestamp. Then as min and max SCN within that given time stamp or within that particular second, what is the minimum SCN and maximum SCN. Now, this will clear us, that is within a given time frame, let us say second, within that given second there can be several SCNs, because that is why if you track the min and max value, we can witness that one. It is a proof within a given time frame, within a given second there can be more than one SCN, otherwise the min and the max value should be same. So, if you query this one now, for example, in this query you can see now 9:11 and 15 seconds I have min and max. So, my min value was 906 and max value was 942. So, see there has been nearly 38 or 13 SCNs were there within that same second, and here also 943, 957 SCNs within the 20 per second, again 51 to 79. But if you get these time frame 27 seconds, no, there has been only one SCN, min and max are same, min and max are same likewise. So, again, even if I re-execute the query, depends on the database operations, even if I re-execute the query, I should be able to get, now you can see you don't have that much of changes at the moment, 31, 32, 33, same, min and max are same, 36, 37, 38, 39, 40, 41. So, it depends on the database operations. 47, here we have a change, see 48 and 52, in that moment 13 second, 933, 13 second, we have 48 and 52. So, there has been 4 SCN numbers, min and max value. So, this query what it will retrieve, you can see select flashback get system change number, it is calling that function. You can see the function that we discussed earlier, and it is getting the level hierarchical function, and from dual and fetching the plus 100 rows and group by SCN to timestamp and order by. So, two group functions, group function and order by function is being used. So, that will map to here min SCN and max SCN. So, that is what the query does, and it is explaining us, the query output explaining us that a given moment there can be multiple SCNs. So, that is the output from that. With that, yeah, let us stop here and we go to the next practical, because as I said, I am not going to drag for long time with these SCN practicals. So, little by little let us try to understand. So, in the next practical, let us run a transaction let's do a let's say creating table, inserting, updating, and let's see how the SCNs are going to behave. Whether it's going to assign per transition basis or whether it's going to be assigned for multiple transition, how a for loop is going to work. So let's test those things in the net practical. Fine, I'll meet you soon. If you like the video, you can subscribe to the channel. I'll meet you soon in the next session. Okay, bye bye, have a great time.